I am going to try and explain what water of crystallization is. I've got copper sulphate here. I've got the two varieties, hydrated copper sulphate and anhydrous copper sulphate. Let me show you. That's the hydrated. The hydrated copper sulphate is blue, as you can see. And it's blue because copper ions with water give that blue colour. So within those crystals, I mean, that's dry, that's not wet. These crystals, there's water trapped inside, and that trapped water is water of crystallization. It's that water there. The .5H2O, the formula CuSO4.5H2O, the .5H2O represents the water of crystallization. If you remove that water of crystallization, then you have copper sulphate that has not got any water of crystallization. And that's called anhydrous, and that's this stuff here. So anhydrous copper sulphate is just CuSO4. There's no water in this formula. Can you see the colour? The colour of it is white. So you need to know about anhydrous. Without any water of crystallization, and without water, copper ions will then not be blue. They're only blue if copper ions and water are present together, and the hydrated variety is there. Now, I want to try this experiment. I've never done it like this before, but if I put the hydrated into a test tube, like this, and clamp the test tube so that it's pointing down a bit, and then I heat it. What should happen is the heat drives off the water of crystallization, drives it off from the blue crystals, and then the water will escape as steam, and you might see the steam. Further along the test tube, it will condense, and I'm hoping we'll get droplets of water. I'm hoping we'll get droplets of water coming out at the end. And if I point it down, I'm hoping those droplets of water will drip into this beaker here. So I've got a beaker. Beaker's got water in it from a tap. That's not important. Can you see the steam coming off? That's the water of crystallization. That steam coming off is water of crystallization that was inside the crystals. And I'm driving it off. You should be able to see the droplets of water further along the test tube. And you should also be able to see that the blue colour of the copper sulphate is changing to white as the water of crystallization is lost and being driven off. Now, I can't seem to get the inside middle of that test tube hot enough to drive off the water because it's staying blue. If I could get it hot enough, then the blue colour would go completely. So wherever you see any blue colour, that is because of water. So anhydrous copper sulphate anhydrous copper sulphate is being formed. That's the white copper sulphate, and the bits of it that are blue or the bits of it that have not had the water of crystallization driven off. Now, there is one more demonstration I'd like to do, which is the opposite of that. So look, if I start here with the anhydrous copper sulphate, I start with the anhydrous. One of the things you need for GCSE is the test for water, the presence of water. So that's the anhydrous, that's the white copper sulphate. And if I get some water, this is just a beaker of water, pour that in there, you should see the white copper sulphate, you should see it go blue, watch. And as you do that, that test tube gets hot because it's an exothermic reaction. Lots of heat comes off. So you've turned your anhydrous copper sulphate, which was white, into hydrated copper sulphate. By adding water, the water gets locked inside the solid of your copper sulphate and makes hydrated copper sulphate. And that's the most famous example of water of crystallization. But there are many salts where the water of crystallization is present and they're white. In the hydrated form they're white, and when they're anhydrous they're white. So a lot of them you don't notice it's there. With copper sulphate, because of the two different colours, the blue and the white, it's quite visual, and therefore we demonstrate it. So I just want you to know it's trapped water, but it's not random. If you look at the formula, copper sulphate, for every 1 mole of copper sulphate, there are 5 moles of water. That's exact. It's not random. It's the way the water is trapped between the copper ions and the sulphate ions. The way that it's all trapped means necessarily there will always be, in hydrated copper sulphate, a ratio of, for every 1 mole of copper sulphate, 5 moles of water. And you quite often have to do a moles calculation to work out how many moles of water are trapped per 1 mole of chemical in these water of crystallization moles calculations. Okay, so if you understand what water of crystallization is, then moles calculations to do with water of crystallization are something that you need to practice. So good luck with that.